Let's go. Okay, let's start. Okay, so in yesterday's lecture, we have discussed about alcohols, the nomenclature of alcohols, and then we have the reactions involving alcohols. Okay, next we have tests to distinguish classes of alcohol. So in general, we have three types of alcohol. One is primary alcohol. We have methyl alcohol, and then we have primary alcohol. Then secondly, we have secondary, and thirdly, we have tertiary alcohol. Okay, so we can distinguish this alcohol via few tests that we can simply conduct in the lab. Okay, so one of the tests is known as Lucas test. Okay, so Lucas test is when you react the alcohols, okay, with a solution of zinc chloride in concentrated HCl. So this zinc chloride in HCl, concentrated HCl, is known as Lucas reagent. So this Lucas reagent, when it reacts with alcohol, okay, so as I've said just now, we have three types of alcohol, so we have primary, secondary, and tertiary. So it will produce different results. Okay, and then from there we could differentiate the type of alcohol lah. Okay, all right. So if this Lucas reagent react with tertiary alcohol, we will see the cloudiness immediately. Okay, and then if this Lucas reagent react with secondary alcohol, the cloudiness will still take place. It's just that it will take longer to appear. Okay, it takes about 5 minutes to appear. Whereas for primary alcohol, it shows no cloudiness. Okay, so you familiar tak? Kalau tertiary alcohol, so dia ada chlorine dekat sini and Cl dekat situ. So halogen will be replacing the OH. So it's like nucleophilic substitution. But the one that give positive result, the one that produce cloudiness immediately. So you boleh agak-agak tak dia punya type of nucleophilic substitution dia. What type of nucleophilic substitution yang prefers tertiary alcohol? Guys? Nucleophilic substitution that prefers tertiary alcohol? Based on what we have learned. Sorry? SN1. Okay, very good. So, in another word, we could say that Lucas test is actually SN1 reaction. Because why? It prefers tertiary alcohol. Okay, because when we react this Lucas reagent with tertiary alcohol, it produces cloudiness almost immediately. Okay, sebab dia react dengan HCl. HCl, basically we use HCl during the reaction of alcohol in SN1. Kan kita pakai HCl kan, tapi kalau kita pakai, kalau for SN2 kita tak boleh pakai HCl. We cannot use HCl. We have to use PCl5, PCl3. Okay, right. So that would be SN2. This one SN1 kita pakai HCl, concentrated of HCl. So that's why tertiary alcohol give cloudiness almost immediately. For primary alcohol, it does not show any cloudiness because SN1 produce carbocation. So carbocation prefers tertiary because of its stability. Okay, so this cloudiness represents the formation of alkyl halide. So it is a nucleophilic substitution where the alcohol, the OH group, will be replaced with halogen. Okay, all right. So this is the reaction. Let's see. Okay, so we have 2-methyl-2-butanol, which represent the tertiary alcohol, and then we have 2-pentanol representing the secondary alcohol and 1-pentanol representing the primary alcohol. So when these three are subjected to this Lucas reagent, Okay, so the first one will it will basically the OH will be replaced with chlorine lah. Okay, so the cloudiness appears immediately. So this cloudiness represent this compound sebenarnya. Okay, and same goes to this one, but this is after 5 minutes. But for primary alcohol, there is no reaction. Okay, right. So that is the first test that we could use in order to differentiate ataupun to distinguish the type of alcohol. Lucas test ataupun SN1. Okay, nama dia Lucas test. Okay, alright. Secondly, we could use oxidation test. Okay, so we could use oxidation test in order to differentiate the classes of alcohol, because we know that primary alcohol can be oxidized. Okay, can be oxidized further into carboxylic acid. Kita dah belajar semalam. Secondary alcohol can be oxidized into ketone. But tertiary alcohol cannot be oxidized. Why? Because tertiary alcohol doesn't have the hydrogen that directly attached to the carbon. That hydrogen is known as oxidizable hydrogen. Tertiary alcohol doesn't have that hydrogen. So that's why tertiary alcohol will give negative result. That means it won't react with, it won't give results for oxidation test. Okay, all right. So like I said, only primary and secondary alcohol are oxidized by hot acidified KMnO4 or hot acidified K2 potassium dichromate. So these two are the are very strong oxidizing agent. Okay, all right. So what actually happened for the observation for reaction with hot acidified KMnO4? Okay, so we are already very familiar with KMnO4. So KMnO4, the color is purple, right? The purple solution color. So when it gives positive result, it shows that the purple color of KMnO4 will be decolorized. That means it will initially purple, then it become colorless lah. So that is what we call decolorization if you are using KMnO4. Okay, but if you are using potassium dichromate, the initial color of this dichromate is orange sebenarnya. Tapi kita jarang guna dichromate, kita guna KMnO4. I think because of the preparation and the stability of chromate. Okay, the orange solution changes to green. Okay, orange solution changes to green. So cantik lah kalau orange tu bila bagi positive result, it will change to green. But there is no reaction for tertiary alcohol because again, why? There is no oxidizable hydrogen attached to the carbon that bears the OH group. Bukan tengok hydrogen yang tempat-tempat lain yang directly attached to the carbon that also directly attached to the hydroxy group. Okay. Done. So far kita ada Lucas and then we have oxidation. Next, last one will be iodophone test. Okay, iodo stand for iodine lah. Okay, that means we will use iodine in this test. Iodophone test is a test to identify methyl alcohol group. Okay, so iodophone test is rather specific test. Okay, sebab dia dah not only to differentiate the alcohol, dia sebenarnya bukan semudah itu, dia lebih spesifik. Dia detect the methyl and also the OH. Okay, they detect the OH and also the methyl group. Maksudnya, in the molecule, it need to have the OH and methyl and also hydrogen. Okay, so because sometimes iodophone test ni is known as oxidation juga sebenarnya. Sebab dia kena ada hydrogen dekat situ. This is if we're talking about alcohol. Okay, later kita akan ada untuk aldehyde and ketone juga for iodophone test. Okay, so dia punya highlight will be the methyl alcohol. So they detect on the methyl. Okay, so alcohol containing methyl alcohol group react with iodine in aqueous sodium hydroxide will produce pale yellow solid of iodophone CHI3. Okay, so these are the reagent. Okay, react with iodine in aqueous sodium hydroxide. Okay, so this is the results ataupun the observation. If it give positive result, that means you akan observe pale yellow solid will form in the test tube that represent the CHI3. Okay, so example. So example of alcohol that give positive result in iodophone test is ethanol. So maksudnya not all alcohol can be subjected to this iodophone test. Okay, you nak kena check, you nak test apa sebenarnya. Sebab, okay, why is it ethanol give positive result to this iodophone test? Okay, sebab dia detect satu methyl, satu alcohol, and it also must have the hydrogen. Sebab later, this one will be oxidized into, remember this? This is like macam carboxyl group kan? Tambah H sikit, dia dah jadi carboxylic acid. So we need this hydrogen in, to oxidize the alcohol lah. And the OH also will be oxidized. And the most important thing is this methyl. Kalau tak ada methyl group ni, okay, yang directly attached to the carbon, it won't give positive result. Okay, so walaupun dia alcohol, tapi kalau dia tak ada this methyl group attached to the carbon, it won't give positive result. So that's why saya kata dia very specific for iodophone test. Dia punya target of alcohol is very, very small. Okay, very limited. Okay, like for example, we have contoh ni kan, the iodophone test can be used to distinguish ethanol from methanol. So we could use, we can distinguish ataupun differentiate ethanol from methanol or 2 propanol from 1 propanol. Kita boleh differentiate. Okay, alright. So kalau positive iodophone test, ethanol will give positive iodophone test because why? Dia ada OH, dia ada H and CH3. Kenapa methanol bagi negative result? Dia ada H, dia ada OH, but this carbon is not attached to methyl group. Dia seorang-seorang je kat situ. Okay, dia mesti methyl, bukan ethyl, bukan butyl, bukan isobutyl, bukan. Dia group dia mesti methyl. Okay, baru dia bagi positive result. So that's why ethanol give positive result compared to methanol, even though both of them also are alcohol. Okay, how about 2 propanol and 1 propanol? Why is it 2 propanol give positive result to and 1 propanol doesn't? Okay, kenapa dia tak bagi positive result? Okay, cuba tengok. Again, dia detect apa? Hydrogen, OH and methyl. Dia kena ada these 3. Okay, for this alcohol. So kalau dia ada these 3, then it give positive result. Okay, but why 1 propanol tak bagi positive result? Because, okay, look at this carbon. Okay, dia ada OH, dia ada H. But this one is not considered as methyl. This is ethyl group. So dia tak dikira. Okay, jangan tengok yang ni. Ini memanglah methyl, tapi dia bukan macam tu. Dia tengok this group that directly attached to the carbon. So this is ethyl, not methyl. So that's why 1 propanol give negative results. Maksudnya no pale yellow solid color form for methanol and 1 propanol. So ni positive result, maksudnya ada pale yellow color solid form. This is due to CHI3. This one. Okay, so iodophone test ni dia specific sebenarnya. Okay. Alright, checkpoint 26. Okay, so very quickly, let's do it. Let's solve this checkpoint together. Okay, given 3 types of alcohol, answer the following question. Identify the alcohol that did not react with acidified KMnO4 solution. Okay, alright, so far what we have learned yang sebelum ni previously, alcohol that won't react with KMnO4 adalah, guys, apa? Adalah alcohol yang won't react with oxidizing agent. Apakah?
Tertiary alcohol.
Very good. It's tertiary alcohol. Tertiary alcohol cannot be oxidized sebab there's no hydrogen. Okay, so you have to identify A, B dengan C yang mana tertiary. Okay, so cari OH tu and then go for that carbon yang pegang OH tu, then identify is it secondary, tertiary or primary. So this one is secondary carbon. Secondary carbon, yeah. So this whole molecule is secondary alcohol. How about this one? Okay, so this is the OH. So this is the carbon that directly attached to the OH. So this carbon is attached to another 3 carbon. So this is tertiary. How about this one? Okay, focus on the OH guys and then cari carbon yang pegang OH tu. Jangan pergi tengok kat kawasan-kawasan lain. Fokus. Okay, look for the carbon yang directly attached to OH. So this carbon. So this carbon is only attached to another carbon. So this is primary. Okay, jangan pergi tengok kat tempat-tempat lain. Fokus. Yang tu just nak bagi confused je. Okay, alright. So the answer will be C. No. By. Okay, B. Okay, identify the alcohol that will produce cloudy solution immediately upon addition of Lucas reagent. This is Lucas test. So Lucas test is also known as SN1. SN1 prefers tertiary. So yang mana tertiary tadi? Dah identify. It is B. Okay. Alright, lastly, identify the alcohol that give a positive result to iodophone test. Okay. Kita kena tengok clearly, kita kena check because iodophone test give positive result kalau dia ada OH, methyl, and hydrogen. Okay, so kita kena check each one of them. Okay, so how about this one? Okay, ini sebenarnya ada hydrogen, right? Okay, this one, kita ada OH, kita ada hydrogen, but do we have methyl attached to this carbon? No, we don't. But we have this one, this bulky group. So it's not included in iodophone test requirement. Okay, so C is out. Okay, how about B? Okay, B kita identify dulu. This carbon cukup tak dia punya 4 bonds? Okay, dah cukup. Dia tak ada hydrogen attached to it. So dia ada OH, dia ada methyl group there, but this carbon does not attach to hydrogen. So B is also out. Okay, dia tak fulfill the hydrogen. Okay, how about this one? Okay, right. So this carbon, it has 1 hydrogen attached to it sebenarnya. Kalau skeletal tak nampak. Okay, alright. So kita check. We have OH, we have hydrogen, and also methyl group. Okay, so dia satisfies all the 3 requirements for iodophone test. Therefore, the answer will be A. Okay, alright. B, A, alright. Okay, ke so far related to alcohol before we proceed?
Okay.
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 Alright. Okay, very good. Okay, guys, very good. Okay, now let's move on to the second last subtopic of topic 5, aldehydes and ketone. Okay, so just to let you know that after alcohol, we don't have mechanism anymore. Kita tak cover lah in our syllabus. I'm talking about our syllabus. So every reaction has its own mechanism. But for our syllabus, aldehyde, ketone, carboxylic acid, and ester later, we won't have we won't be having any mechanism dah. So you punya mechanism stop sampai alcohol kot. Kalau kan highlight alcohol. Okay, so maksudnya bila tak ada mechanism kat situ, banyak memorization yang perlu dibuat. So you tengok reagent, you kena ingat, okay, what is the name of the reaction, the reagent, the product form. Okay, so banyak memorization yang berlakulah di situ. Okay, so these are the learning objective. As you can see, every functional group pun banyak lah dia punya learning objective. Okay, alright, so these are the learning objective for aldehydes and ketone. Okay, the carbonyl compound. Okay, right. So the introduction part of aldehyde and ketone, structure-wise, okay. So aldehyde and ketone both contain this carbonyl group C double bond O. Okay, so the general formula for aldehyde will be R CHO like this. CHO. Okay, dia ada this carbonyl group. Whereas ketone have the general formula of this. C double bond O and R. So R represent carbon lah, carbon group, alkyl group. Okay, so like I said, so ketone usually, the carbonyl group usually located between the carbon. Whereas aldehyde, dia duduk terminal, dia duduk dekat tepi. Okay, dia macam carboxylic acid. Cuma carboxylic acid, it is attached to OH, right? So aldehyde, it is only attached to hydrogen, but it can be oxidized into carboxylic acid. Okay, alright. So that's the difference between aldehyde and ketone. Satu duduk dekat terminal tepi, the other one duduk dekat between the carbon. Okay, so example of aldehyde is methanol. Methanol is also known as formaldehyde. So this formaldehyde is very dangerous. Okay, it has pungent gas. It is a pungent gas. Okay, and then it is also known as formalin. Okay, formalin is a preservative. So formalin is normally used to preserve something like mayat. Okay. Apa nama tu, serangga, insect, okay, and wood smoke, it can be produced from, apa nama tu, it is also known as wood smoke, and it is also carcinogenic, okay, so don't expose yourself too long with methanol, because it is carcinogenic, it can cause cancer. Okay, and then 2-propanone is an example of common ketone lah, common compound of ketone, or also known as acetone. Okay, it is famously known as acetone. So it is commonly used as nail polish remover. Okay. So these are the application ataupun kegunaan aldehyde and ketone in our daily life, especially in foods. Okay, many aldehyde and ketone have pleasant taste and aromas. Okay, so we can have aldehyde in butter, okay, yang bagi bau butter tu is due to this butanol. Okay, and then vanilla, you tahu vanilla, bau sedap vanilla tu is actually due to this vanillin. Dia punya compound tu nama dia vanillin. Okay, dia punya active compound, dia punya ingredient in the vanilla, apa nama tu, dia punya yang cause the scent tu, bau dia tu adalah due to this compound. Okay, in almond we have benzaldehyde, in cinnamon we have this cinnamaldehyde as the compound lah, as the main compound. Okay, that is for aldehyde. This is for ketone. Dalam pistachio we have acetophenone, spearmint we have carvone, raspberry we have iodophone, and then mast as muscone. Okay, we have muscone in mast. And so nama dia tu due to the presence of the compound, the active compound ataupun dia punya main compound in the substance. Nama dia tu diberikan sempena that main compound. Okay. Ini lah. Ini ketone. Nampak tak dia duduk dekat tengah-tengah antara dua karbon. Mesti antara dua karbon. Tapi kalau aldehyde, nampak dia dekat terminal. See? This one. This one, ni semua dekat tepi. That would be aldehyde. Okay, name it. Okay, find longest carbon chain containing C double bond O. You must your parent chain must consist of the carbonyl group. Okay, kalau aldehyde, dia punya ending dia tu you kena ends with Al. Kalau ketone, dia punya ending should ends with on. Like just now, butanol. Okay, it ends with Al, right? So that is due to aldehyde. Okay, and ketone just now apa tadi? Macam propanone ke kan? Maksudnya there is a presence of carbonyl group as ketone lah. Okay, okay. Step number 2 for aldehyde, number the main chain from CHO group. The carbon will be assigned as carbon number 1. Like I said, aldehyde dia duduk dekat terminal. Okay, dia duduk dekat tepi. So, kalau you nampak je aldehyde, you kena start numbering the carbonyl group tu as carbon number 1. Mesti carbon number 1. Okay, as for ketone pula, ketone ni dia duduk dekat tengah. Dia between the two carbon. So, kita punya approach adalah number the main chain begins at the end nearer the C double bond O group. So, obviously, ketone tak boleh dapat nombor 1. Carbon tu tak boleh pegang nombor 1 sebab dia duduk between the 2 carbon. So what we can do is try to get as lowest number as possible for that carbonyl group. So you kena consider, tengok dia punya chain dia tu nak kena start daripada this end ataupun that end. Yang mana yang produce the least number ataupun the lowest number for the ketone, for the carbon yang having the carbonyl tadi. Okay, and then macam biasa, identify and number the substituent and then write the name as a single word. Okay, let's look at the example. So this is an example of aldehyde. As you can see, dia duduk dekat tepi. Okay, you macam biasa, you kena identify the longest parent chain including the carbonyl group. So maksudnya this will be carbon number 1. So you kena try. Either you pergi straight ataupun you going down. Sorry, you go down. Okay, yang mana yang produce. So either one pun you produce 3 carbon. Ke bawah pun you produce 3 carbon. So doesn't matter. Dia akan produce nama yang sama. So that's why you dapat propanal because it is an aldehyde. And then dekat carbon number 2 we have methyl, right? 2-methyl propanal. How about this one? Okay, mesti include this one. Dia mesti sebagai nombor 1. Okay, so yang paling obvious would be dia lah yang straight. Kalau ke bawah kita hanya dapat 1, 2, 3, 4. Ke atas pun 1, 2, 3, 4. Okay, straight. So kita akan dapat pentanal paling panjang. Okay, alright. How about this one? Okay, ini inclusive. So paling cuba kita try straight ataupun kita turun ke bawah. Compare. Which one will produce the longest parent chain? So obvious one yang straight ni lah. Okay, we have 6 carbon. So it is hexanal because it is an aldehyde. At carbon number 3 we have berapa? Ini. And this is isopropyl, right? Okay, dia ada CH3 and ada CH3, isopropyl. Tak nak bagi nama isopropyl? Boleh, tak ada masalah. You can use the bracket one. This one would be named as 1-methyl ethyl. Okay, 3, 1-methyl ethyl. Okay, hexanal. Okay, sebab this, katalah this would be the parent lah. So this would be the substituents. Okay, alright. How about ketone? Okay, ketone like I said, dia mesti duduk between the 2 carbon. Kalau this one, between this carbon number 2 and carbon number 4. Okay, so this is obviously the longest lah. Mana ada, tak ada lain lah kan. So kita kena start from this side sebab dia produce 3, the carbonyl will be located at carbon number 3. Kalau kita start from here, kita akan dapat 1, 2, 3, 4, 5. Kita akan dapat dekat carbon number 5. So dia besar. So that's why we have to start from here, not from here. Okay, so it is 3-heptanone. Okay, this is also in the middle. Maksudnya between this one. Okay, make sure you can identify. Jangan pilih this one sebagai you punya parent. Sebab apa? Sebab dia tak include the carbonyl. Dia mesti include the carbonyl as the parent. Barulah nama belakang dia boleh pakai ketone. Okay, alright. So 1, 2, 3, 4, 5, 6. Try macam tu ataupun 1, 2, 3, 4, 5, 6. Ke bawah lah. Okay, ke bawah. Sebab kenapa sama je kan? Ke sini pun 6, ke sana pun 6. Tapi kalau kita pergi ke sini, ke bawah ni, dia produce more substituents. Produce more substituents. Kalau you pergi daripada sini, pergi ke sini, you hanya produce this chunky substituents. Satu je substituent. So it's not preferable. Okay, so from up here, going down, and here. So you ada methyl and also ethyl. It ends with ONE. Same goes to this one. Ni paling obvious. Ni paling panjang kan. Boleh nampak. Ataupun you boleh try out this one. Ni kurang 1 kan. So we have ethyl group there. Okay. So we should start from here. Therefore we get carbonyl group at carbon number 3. So it is 6-ethyl 3 nonanone. Okay. So name the following compound using the IUPAC system of nomenclature. Maybe you can try out this one, B. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Still 7, so it is heptanone. Why is it heptanone? Because this is ketone. Because this is C and this is also C. So it is ketone. So this carbonyl group is located at carbon number 2 because we're going to start numbering from this end. So it is 2 heptanone and then 1, 2, 3, 4, 5, 6. Okay, at carbon number 6 we have methyl group, 1 methyl group. So it is 6 methyl group. 6 methyl 2 heptanone. Okay, alright, maybe we can try A. Cuba try A. Okay, kat sini, don't get confused Jangan tersepit di antara rantai paling panjang dengan functional group. Okay, ini memanglah dia ada 6 carbon. Tapi this one we have functional group here. So nak ambil yang mana? Okay, kita ambil yang functional group. Rantai yang ada functional group, yang consists of functional group. So this is aldehyde, right? So it has 1 carbon there. 1 carbon. So it is methanol. Okay, sebab dia hydrogen kan, dia bukan ketone, dia methanol. At carbon number 1, we have this cyclohexyl. Okay, so cyclohexyl methanol. Sebab dia located at carbon number 1. Bolehlah satu cyclohexyl methanol. Okay, sebab dia ada 6 carbon. So cyclohexyl. Dia jadi substituents lah, YL. Okay, faham ya? Okay, so ni boleh try out sendiri, boleh try namakan C dengan D lah. Okay, alright, so kita dah try. Okay, reaction. Okay, okay, so far okay ke naming tadi, nomenclature? How are you guys doing? Are you guys doing okay so far?
Okay.
So far so good.
Okay. So far so good Alhamdulillah. Okay. Saya baru perasan rupanya awak exam Jumaat ni bukan Jumaat ni, Jumaat depan Okay, so maknanya your carry mark. Okay, saya kena keluarkan by this weekend lah. Okay, by this weekend. Supposedly tomorrow tapi tak siap lagi. So by this weekend lah, I try to release the carry mark by this weekend. So that you can prepare lah. You have that ample time to plan for your exam. Okay? Okay. Okay, jom start. Bismillahirrahmanirrahim. Next will be the reaction involving aldehyde and ketone. Okay, so the name of the reaction in general involving aldehyde and ketone is known as nucleophilic addition. Why is it addition? Because it has double bond there. It's not substitution, it is addition. Okay, all right. Of carbonyl compound, the carbonyl group in aldehyde and ketone has a constant polarity. Okay, as you can see, oxygen is more electronegative than carbon. Like I said last time, this will create unequal sharing. Okay, so the carbon will be slightly positive and oxygen will be slightly negative. So carbon will become electrophilic ataupun dia behave as an electrophile. So it is prone to nucleophile attack. Sebab dia slightly positive kan? Dia electrophile. So nucleophile akan attack this carbon. Okay. Aldehyde are generally more reactive than ketone in nucleophilic addition because of steric effect. Because of steric effect. So in comparison to aldehyde, to ketone, aldehyde is more reactive ataupun more it is easier to perform reaction using aldehyde because of the steric effect, the steric hindrance effect. Because kenapa? Aldehyde dia duduk dekat terminal. Dia ada hydrogen dekat sini. Kalau compared to ketone contohlah, simple ketone. See, dia ada dua bala tentera dia dekat sini. So steric hindrance means cloud of electron dekat situ. This cloud of electron will cause the nucleophile attack will be very difficult. Sebab ini kawasan-kawasan yang maksudnya intense lah. Maksudnya for nucleophile to attack the carbon, it will be very difficult. Compared to kalau aldehyde. Aldehyde dia ada hydrogen saja. And of course lah ada this one. Tapi compared to this and this, okay, hydrogen ni allows the nucleophile to attack easily. the carbon. Okay, so that's why dia kata more reactive. Because of steric effect, it is sterically less hindered. Okay, dia punya ruang tu senang nak penetrate compared to ketone because it is only attached to only one substituent, which is this part lah. Katakanlah this one this part. This one substituent. This is not considered as substituent. This is hydrogen. Okay, tapi kalau ketone dia ada dua substituent, so it will be very hindered. Okay, more hindered. Okay. Alright, so start. Okay, addition of CN to C double bond O. CN is a nucleophile, CN minus is a nucleophile. Okay, so polar molecule HCN adds across the C double bond O. So the target will be on the C double bond O. So you don't have to concern about other alkyl group. Just focus on the carbonyl group because that is the place where the reaction will take place. Okay, so that add across the C double bond O with the positive part hydrogen attaching to O. Okay, so dia ada HCN kan, so dia akan produce H dengan CN. So H plus akan attach kepada O. Ni, this one C double bond O kan, dia akan attach pada O, whereas CN akan attach kepada carbon. Sebab carbon kan dia slightly positive, oxygen slightly negative. Okay, so positif dengan negatif dia mix well lah. Okay, dia attracts. Okay, so methanol, HCN is the reagent. Okay, so what happened is that kalau you belajar mechanism, dulu kita ada mechanism, but now we don't have it anymore. Okay, we exclude the mechanism out from the ni lah. Okay, so what happened is that this bond nanti CN ni sebenarnya dia akan attack daripada belakang. Okay, and attach itself to the carbon. So that's why you nampak ni, dia attach dari dekat belakang. Okay, whereas this hydrogen, so nanti bila dia dah form bond kat sini, double bond ni tak boleh dah berada dalam keadaan double bond sebab nanti dia ada 5 bond pula dekat situ. Okay, alright, so this bond, the pi bond will be broken down, leaving the O saja, so O negative. So hydrogen yang tadi ni hydrogen kan plus, so it will be attracted. So the O nanti akan attack the H, so that's why dia akan jadi OH. Okay, tapi sebab kita tak ada mechanism, so you just kena ingatlah CN akan attach kepada C tu. O ni dia akan ambil the H, dia jadi OH. Hilanglah dia punya double bond. Kalau dia double bond nanti dia ada 5 bond pula, tak boleh macam tu. Okay, so this compound is known as cyanohydrins. Dia ada cyano ni, cyano group. Hydrins mean OH. Hydrins. Okay, it's the same thing. Okay, so we can add in the CN to C double bond O lah. So ini pun menyebabkan pertambahan rantai juga ni. Sebab ada pertambahan carbon there. Okay. Okay, checkpoint. Okay, draw structural formula for the product formed by treating each of the following compound with HCN. Okay, alright. So maybe kita boleh try out simple saja sebab dia nak produk je. Dia tak tanya mechanism pun. Okay, alright. So katakanlah A ni kan, react dengan HCN. Okay, jadi apa? Okay, so CN akan add dekat belakang ni, H akan join dekat O tu. Simple je. Okay. Buat yang sama, exactly the same, O, H, sama CN. Cuma ni, ini H lah. Tapi you tak payah buat H pun tak apa kot. Okay, kalau tak you kena buat H. Kalau you tertinggal H, nanti orang ingat metal. It's not metal. Ini dia highlightkan because dia nak tunjuk yang itu adalah aldehyde. If not, let's just remove. So dia jadi macam ni. Okay, ataupun you nak cantikkan, you buat macam ni. So it will be CN lah. Sebenarnya ada satu hydrogen dekat situ sebab skeletal. Kalau tak, kalau you nak buat, nak tunjuk, you kena tunjuk H ni. Kalau you hilangkan H tu, you biar dia macam ni, itu metal Jangan confuse. Okay, alright. So this is ketone. Kan? Ketone ke aldehyde ke doesn't matter. It will add the same, similarly. Dia akan add secara sama lah maksudnya HCN. Okay, so you akan buat salin balik exactly the same. Kat sini ada satu metal kan? So 1, 2, 3, 4, 5, 6. So this one akan masuk CN. Dekat carbon yang sama, identify carbon tu. Yang lain tu remain the same. Tambah dulu. Make sure dia complete. Okay, you boleh tambah CN dekat sini. And then O ni akan tambah H. Sebab you kena guna H dengan CN. Dah siap. Okay, very simple. How about this one? Ni pun sama. Identify carbon yang ada carbonyl tu. So this one. So sebenarnya this one. Yeah. Okay. Alright, sama je. Okay, react with HCN. So O. Okay. So dia ada CN. Lagi satu. Don't forget this one akan jadi OH. Jangan lupa ni methyl group ni kan tertinggal pula. Methyl. Salin dulu biar lengkap. Siap. Okay. Ni boleh buat sendiri lah. Boleh buat sendiri. Simple je. Okay. Right. Done. Next is addition of Grignard reagent to C double bond O. Tadi nucleophilic. Apa tadi? Addition of CN to C double bond O. Nucleophile lah. CN is nucleophile. Nama dia Nucleophilic Addition. So they add in the CN minus to C double bond O. Okay, alright, next we have addition of Grignard reagent to C double bond O. So last time we have prepared the Grignard reagent, right, using alkyl halide. Okay, now we are going to use this Grignard reagent in this reaction. So it is used in this nucleophilic addition of carbonyl compound. Okay, so Grignard reagent are powerful carbon nucleophile. It can behave as nucleophile. Powerful, in fact. Okay, the carbon in the Grignard reagent is a powerful nucleophile. Okay, they undergo addition reaction with aldehyde and ketones. So basically methanol, if you have methanol, this is methanol, okay guys? Ni methanol. So when you use methanol, reacts with Grignard reagent. Ingat lagi tak Grignard reagent ni? MgX. This is Grignard reagent. When you react methanol with Grignard reagent, it will yield primary alcohol. Methanol saja, dia aldehyde, tapi kita specify methanol saja yang produce primary alcohol. Other aldehyde, okay, when it reacts with Grignard reagent, it produce secondary alcohol. As for ketone, ketone as a whole lah. Okay, ketone when it reacts with Grignard reagent, it produces tertiary alcohol. Okay, it produces tertiary alcohol. So kena ingatlah ni So kalau aldehyde other than methanol, it produce secondary alcohol. Terus je, okay. Kalau keluar objective question, nampak dia aldehyde, normal aldehyde, panjang-panjang, ada rantai panjang lah, apa, branching ke apa, whatever. As long as you have identified as aldehyde and then reacted with Grignard reagent, it will produce secondary alcohol. So cari dekat dalam jawapan tu ada tak yang produce secondary alcohol? Ada tak jawapan ni secondary alcohol? That will be our first target lah. Okay, so remove all the primary alcohol. Primary and tertiary dah totally out. Sebab dia adalah common aldehyde. So unless it is methanol, it will produce the primary alcohol. Okay, alright. So it is an excellent method for synthesis of alcohol. Okay, kita boleh synthesis alcohol using this Grignard reagent, reacted with carbonyl compound, ketone or aldehyde. Okay, contoh, jom tengok contoh. So we have methanol. So like what we had earlier, methanol react with Grignard reagent will produce primary alcohol. Okay. Alright, so this is the Grignard reagent. Ni Grignard reagent dia. So tak kisahlah belakang ni apa, tapi depan ni MgBr. Okay, dia nak masukkan this rantai, this R group into this molecule into methanol. Nak memanjangkan rantai lah. Ini nama lain untuk this Grignard reaction is also known as lengthening the chain. Boleh memanjangkan rantai. Okay, alright. So, kenapa dia kata a good nucleophile for Grignard ni? Sebab apa? Mg kan plus. Kan? Charge dia memang plus. Dia memang electropositive. So, kalau dia ni plus, what happened to the carbon? Carbon mestilah minus. So, dia behave sebagai carbanion. Okay, so dia adalah nucleophile. It's a good nucleophile, powerful nucleophile. So, dia sebenarnya nanti, kalau again, with reference to mechanism, it will attack from behind. The carbon ni, yang negatif ni, it will attack from behind. Okay, dia break, dia akan attack from behind and attach itself. Nampak tak ni? Dia attach kat belakang tu. So, bila dia attach dekat belakang tu, pi bond ni kena break. Kalau tak, dia nanti dia ada 5 tangan. 5 tangan, 5 bond. Ada double bond, lepas tu ada bond lagi kat belakang tu. Ada 5, tak boleh. So, dia kena break. Okay, so dia break, dia bagi dua lone pair tu kepada O. So, O tu dia jadi negatif. Okay, so dia akan attack H3O plus kat sini. Sebenarnya. So, dia akan jadi H. Jadi OH kat situ. Very good. Okay. So, mekanisme dah tak ada kan. Dulu ada mekanisme, now dah tak ada mekanisme. So, OMGBR. Okay. So, as you can see, this is alcohol. Okay, the hydro ini nanti O tu jadi minus kan, so dia akan attack the H3O plus becoming OH. So this is primary alcohol. Sebab dia start from methanol. Okay, so another type of aldehyde. Let's say propanol lah, apa-apa lah yang al kat belakang tu. So aldehyde lah, normal aldehyde other than methanol. When you reacted with Grignard reagent, basically it proceeds the same way as methanol just now. Okay, cuma dia produce secondary alcohol. See? Okay, macam mana? Okay, ni kan macam saya cakap, dia ni negatif. Dia ni positif. So, dia ni good nucleophile sebenarnya. So, dia akan attack, dia akan attach itself dekat belakang. See? Nampak? You punya kerja, tambah aja, tengok dia punya alkyl group tu, tempik sebiji-sebiji, do not change anything. Tambah aja dekat belakang carbon tu. Dekat carbon tu. So, dia ada ubah apa-apa ke? Nampak? Maintain everything the same. And then, bila dia dah attach dekat belakang tu, dah ada satu bond extra lah kat belakang ni kan. So, the double bond will be broken. Obviously, kena break. Okay, so both of the pi bond tu pi bond akan break. So, both of the lone pair will be given to O. So, O akan jadi negatif dekat situ. So, O ni behave sebagai nucleophile. So, bila dia behave as nucleophile, it will attack. Nampak tak reagent number 2 dia apa? H3O+. It will attack the hydrogen from this H3O+. Dia nak ambil the hydrogen from this H3O+. Therefore, dia becoming OH. Dia become OH. So, bila you identify alcohol, ni alcohol lah. So, you identify this carbon. Okay, it's actually secondary carbon, secondary alcohol. The carbon is secondary, therefore the whole molecule is considered as secondary alcohol. Okay, all right, let's look at the the last example here. So this is ketone. Ni ketone, macam mana tahu ketone? Sebab dia diapit oleh dua carbon ni guys tu. Okay, sama juga. So this is plus, this is negative. So this carbon right here will attach itself ataupun attack dan lekatkan diri dia pada carbon tu. See? You tengok sebiji-sebiji macam tu. You jangan ubah apa-apa. You lekatkan saja everything macam asal. Pap, lekat dekat situ. Okay, and then this one jadi OH. There. Dah, siap. So, you identify. Ini apa? Nampak tak? Dia tertiary. This carbon is tertiary carbon. So, that's why ketone produce tertiary alcohol. Okay? Right. Okay, draw the product form from the reaction of 4,4-dimethyl 2-pentanone and 2-ethyl 3-methyl butanol with isobutyl magnesium bromide in dry ether followed by hydrolysis in aqueous acid. Okay, you nak try yang mana? Nak buat butanal ke nak buat pentanone? Satu contoh. Guys?
Butanal.
Or aldehyde. Ada yang lain agree Agree je lah, nak buat macam mana, dua-dua pun sama je kan. Okay. Alright, so butanal. Okay, you nampak ni butanal kan? So bear in mind, this is not methanol. Kalau dia bukan methanol, of course dia kena produce secondary alcohol. Okay, other than methanol, the product form will be secondary alcohol. Okay, alright, so let's draw 2-ethyl, 3-methyl butanal. Okay, let's draw butanal first from the parent. 1, 2, 3, 4. Buta. 1, 2. Cuba start daripada atas. Saya start daripada bawah ni kan. Okay, tadi mana ni? Produce secondary alcohol. So, butanal 1, 2, 3, 4. Okay, and then this one. 2, 3, 4. Double bond O. H. 1, 2, 3, 4. Always count balik 1, 2, 3, 4. So this is the carbonyl part. And that carbon number 3. So since this is number 1, number 2, number 3. Number 2 kita ada ethyl. This is ethyl. Number 3 we have methyl. Begini strukturnya. Okay. Buat cantik sikit. Inilah. Okay. Alright. So react dengan apa tadi? Isobutyl magnesium bromide. Isobutyl magnesium bromide. So isobutyl is like this. 1, 2, 3. Isobutyl. This is butyl kan? Macam mana nak buat isobutyl lah? Macam mana nak cantik sikit? Ya ke? Bukan. Salah. This is set. Iso mesti ada methyl. Okay? This one. Iso tu sebab ada these two methyl group. And then 1, 2, 3, 4. Mg. Br. This is isobutyl. 1, 2, 3, 4 ada 4. And then kenapa dia iso? Because dia ada 2 methyl yang sama. Okay. Right. So this is isobutyl. React with sempit. Apa dia punya keadaan dia? 1 adalah ether. Dan 2 adalah aqueous acid. H3O+ lah. Basically. Okay. Alright. So apa you kena buat? Dia tak ada tanya mekanisme ke apa kan? Target on the carbon. Okay. Alright. So exactly lukis benda yang sama. Dengan tinggal satu pun. Okay. Alright. So apa ni tadi? Ni double bond O kan? So O tadi. Okay. Dia akan attack from behind. So kita tulis hydrogen ni. Tadi hydrogen. Dia akan attack from behind. Maksudnya this one. So this carbon is nucleophilic. This one is electrophilic. Okay. Alright. So dia akan attack from behind. Okay. Opposite side lah. Okay, so dia attack, dia akan attach itself. So you attach everything ni daripada sini sampai sini you attach. Okay. Tapi asalkan dia betul lah. Okay, alright, 1, 2, 3, 4. This is the isobutyl part. The isobutyl part. Okay, alright, O ni jadi apa? H. Sebab dia attack this one. Dia akan jadi O negatif. So dia akan attack the H. Okay, dia akan attack and then dia ambil the hydrogen. So dia jadi macam ni lah. So identify. Okay, dia punya class of alcohol. Ni alcohol lah ni kan. This is alcohol. Okay, kita nak serabut. So this is alcohol due to the presence of OH here. Due to the presence of OH here. Then identify. Okay, ni you nak terminate pun, nak remain pun boleh, nak terminate pun boleh. So let's just terminate lah hydrogen. Okay, kita pakai skeletal tool. So this carbon is a secondary carbon, right? 1, 2. Allah. Keep. Okay, this is a secondary carbon, therefore it is a secondary alcohol. So proven. Okay, so you try for ketone, so you gonna produce tertiary alcohol, right? Okay, then second reaction of aldehyde and ketone, okay, where carbonyl compound react with Grignard reagent. Next, oxidation. Okay, oxidation of aldehyde. Okay, remember kita belajar alcohol last time. So alcohol, bila dia undergoes oxidation, okay, kalau step by step the process, it will produce aldehyde. And then undergoes oxidation lagi, okay, it produce carboxylic acid. Tapi kalau if we are using very strong oxidizing agent, dia boleh shoot from alcohol directly to carboxylic acid. Dia tak stop pun dekat aldehyde. Tapi this is basically the step lah. Okay, so kalau kita guna mild oxidizing agent like PCC, okay, so it can be the oxidation reaction can be stopped until aldehyde. Tapi kalau kita guna kuat, dia tak stop dekat aldehyde. Dia terus je. Macam laju terus ke carboxylic acid. Okay. Alright. So oxidation of aldehyde. So with reference to this scheme, you nampak ni. Aldehyde can undergo oxidation. Okay. Sebab kita fokus dekat sini aldehyde ni. Sebab kita tengah belajar aldehyde. Yang last time kita belajar alcohol. Tu yang you kena tahu alcohol undergoes oxidation to produce aldehyde and carboxylic acid. Now we are on the topic of aldehyde, therefore you should know aldehyde can be oxidized into carboxylic acid. Okay, alright. So common oxidizing agent, like always, CHM096 and potassium dichromate. Hot CHM096 and potassium dichromate. Okay. However, ketone, how about ketone? Ketone cannot undergo oxidation. Tak boleh undergo oxidation. Why is it so? Because of there's no hydrogen, oxidizable hydrogen. So you know kan, this is aldehyde. So katalah R. So this hydrogen will be oxidized. So that's why aldehyde can be oxidized into carboxylic acid. But for ketone, we don't have hydrogen. There's no oxidizable hydrogen. That's why ketone cannot undergo oxidation. Okay, alright, so aldehyde can be oxidized into carboxylic acid, but ketone cannot undergo oxidation. Therefore, there will be no product formed. Okay, alright, so ini kalau oxidation, guys. Ini kalau oxidation. How about if kita nak reduce? Dah oxidize, reducekan balik pula. Okay, kalau kita reducekan, apa produk yang akan terjadi? Dia reverse lah. Okay, kalau you reducekan this aldehyde, it will produce alcohol lah. Okay, it will produce alcohol. Kalau you ada ketone, you nak reducekan. Okay, okay. Remember alcohol last time yang you belajar tu, is it secondary alcohol kan? Secondary alcohol you reducekan, you oxidize, you akan produce ketone, kan? Tapi kalau you oxidizekan, you reduce this ketone, I'm talking about reduction, you reducekan, maksudnya reverse, you akan produce secondary alcohol. Alah, dia forward reverse, dia terbalik lah. Oxidize, reduce. Okay, so what are the reducing agent that can be used to reduce the carbonic compound? Nabeh 4 yang saya beritahu semalam, sodium borohydrate and also lithium aluminium hydrate. So these are very strong reducing agent. Or alternatively, you can use hydrogen also. Reduce, kan? Maksudnya you include the hydrogen. But don't forget you have to add in the catalyst. So we will use nickel catalyst lah. Okay. Okay, so aldehyde can be reduced into primary alcohol. So aldehyde akan produce primary alcohol. Ketone on the other hand will produce secondary alcohol. Ketone boleh reduce, tapi ketone tak boleh oxidize. Okay, sebab apa ketone tak boleh oxidize? Sebab there's no oxidizable hydrogen attached to the carbonyl group. Itu yang pening. Okay, alright. So ada dah idea tu. Dia sebenarnya pakai balik je yang kita dah kita dah study dekat alkohol tu, kita bring back the info in aldehyde and ketone. Okay, banyak information yang overlap, which is I would say can be helpful lah. It's not something yang new, totally new, tapi dia information yang overlap. Maksudnya you tahu alkohol, and then you akan overlap dengan ketone and aldehyde. So ketone nanti patah balik ke alkohol, aldehyde patah balik ke alkohol. Okay, so itu yang maksud saya of information overlap. Okay, tu saya dah cerita in detail kat sini kan. Jom kita tengok contoh. Okay, alright. Methanol reduction lah. Talking about reduction. Sebab oxidation very simple tadi. Oxidize into aldehyde can be oxidized into carboxylic acid, right? So kalau reduction, okay, let's say we have methanol. Okay, methanol bila kita reducekan dia aldehyde ni. Reducekan dia, it will produce methanol. Okay, alright. This is methanol. Reducekan, maksudnya kita kena pakai lithium aluminium hydrate in ether. And these are the condition lah. Kalau condition means kena exactly this. Tertinggal maksudnya tertinggallah markah you. Okay, so what happen is that oxidize, kan? So bila dia reduce. Okay, so the oxygen will be reduced. So you kena tambah hydrogen there pada oxygen, and not only that, sebab dia supply hydrogen ni, dia nampak tak? Dia ada supply, dia adalah supplier of hydrogen. Dia supply 4 hydrogen. For 1 lithium aluminium hydrate, it is able to supply 4 hydrogen. So not only that, the pi bond will be broken down, so dia tambah lagi 1 hydrogen. Ni baru menunjukkan dia reduce. Kalau oxidation last time, dia tambah oxygen. Okay, so these are the condition for reduction lah yang you kena memorize. Okay, another type of another aldehyde other than methanol, ethanol lah for example. Okay, apa yang you kena buat adalah you jadikan dia OH. Okay, jangan takut dengan structure dia yang macam bulky, macam-macam ada carbon lah dia bentuk. Target on the functional group. Okay, this you identify, oh ini reduction ni. Okay, so what will happen here? Okay, so dia akan reduce. And you can identify lah, this is aldehyde first. Jangan ingat, ketone tak boleh reduce sorry. Betul-betul, ketone boleh reduce. Oxidation for ketone je tak boleh berlaku. Okay, so this is aldehyde. So you jadikan O ni, jadikan H. Lepas tu tambahlah satu lagi hydrogen. Dah siap. CH3 remain. H ni pun remain. Tak ada kena keluarkan apa-apa. Jadi alkin ke apa. No. Okay, so you just tambah hydrogen pada oxygen and another hydrogen to the carbon. Because ni nanti dah break. Bila dah break, dia akan buka lagi satu bond dekat situ. So siapa yang akan masuk? Hydrogen. Okay, alright. How about ketone? Ketone when it undergoes a reduction, ni ketone. Kalau tak berapit. Okay, it undergoes reduction, sama juga. You tambah the OH, you tambah the hydrogen, this one will be broken, so tambah another hydrogen there. Dah, siap. Okay, this is for reduction using reducing agent. Okay. Yeah. Banyak pula. But, okay, another test. Ni apa? This is already chemical test. Okay, done. So those are the reactions for aldehyde and ketone. Okay, for aldehyde and ketone. Apa reaction-reactionnya? Reduction, oxidation, reaction with Grignard reagent. Then what else? Awal-awal tadi reaction with CN minus kan? Ada four reactions so far. So that's all for aldehyde and ketone. Now we are going to we have a test, okay, for carbonyl compound. Okay, this is new new apa nama tu, new subtopic, bukan subtopic, this is new information. Okay, so we never had this slide before, but for your whole batch kita baru masukkan. So be standby lah, standby. Okay. To determine the carbonyl compound using Brady's reagent. Okay, so when Brady's reagent is this 2,4-DNP in short. So this is called Brady's reagent. Okay, 2,4-DNP. So kalau soalan cakap reaction apa nama with DNP, it is also known as Brady reagent. So aldehyde and ketone, as you can see, we have aldehyde and ketone. This is the Brady reagent. Okay, this is the Brady's reagent. Okay, so what happen is that dia akan bercantum. Okay, aldehyde dengan ketone ni dia akan combine. So the H2O will be kicked out. So we have amine group here, right? So H2 dengan O from the carbonyl compound will be kicked out from the molecule and they will be attached together. So this will be the final product. So the final product will produce yellow-orange precipitate. So maksudnya positive result lah. Okay, Brady's reagent will give positive results to aldehyde and ketone for both aldehyde and ketone. Okay, sebab dia boleh react macam tu. Dia directly, maksudnya O will be removed and directly attached to the nitrogen. Double bond tu remain. Okay, nampak tak? Double bond remain. O tu ganti terus dia attach to this DNP. So this one is the precipitate is yellow. The product, the positive result is yellow-orange precipitate when it reacts with Brady's reagent. Okay. Ini extra information lah. For this, we don't have this slide. Brady's reagent. Okay. Baru chemical test. Okay. Chemical test to distinguish aldehyde and ketone. How do we distinguish aldehyde and ketone? So what are the tests that can be used to distinguish these two compounds? First one is known as tolerance reagent, or also known as silver mirror test. Okay, it is unfortunate lah. Okay, so normally this is the experiment that we will conduct in the lab. Tapi this semester you apa nama tu, not be able to perform this experiment. Okay, so you tak boleh nampak benda tu live. Kalau you buat this experiment in the lab, okay, you will produce, at the end of the experiment, you will produce this silver mirror test. Memang you nampak silver and it is a mirror. It is how mirror is produced. Menggunakan silver. So you akan nampak, you tengok the test tube will be coated with this silver mirror and you will see your face. Nama mirror kan? Okay, so this silver mirror test ataupun tolerance reagent, I said it's the same thing lah. Tolerance reagent is a solution of silver nitrate in ammonium hydroxide containing the silver complex of this. Okay, so siapa yang akan bagi positive result to this silver mirror test? Is it ketone or is it aldehyde? The answer is aldehyde. So aldehyde will give positive result to this silver mirror test, but not ketone. Ketone, no reaction. So kita boleh differentiate lah ketone dengan aldehyde. Okay, so aldehyde will produce, ketone give no reaction. So aldehyde will produce silver mirror, whereas ketone will not. Okay, so this is the positive result of apa nama tu, of aldehyde. So sebenarnya tolerance reaction ni adalah oxidation sebenarnya. Oxidation test. You nampak tak? Initially dia aldehyde, nampak tak? Ini kan carboxyl group. Kan? React dengan hydrogen terus jadi carboxylic acid. So it is an oxidation reaction. Sebab initially dia ada satu oxygen, now dia ada dua oxygen. Oxidation reaction. Okay? So that's why aldehyde can, only aldehyde can give positive results to tolerance reagent. So boleh pakailah tolerance reagent ni untuk nak differentiate ataupun distinguish ketone and aldehyde. Another one is Fehling. I think you are more familiar with Fehling. I think Fehling has been used in biologies as well. Okay, nak detect, I'm not sure sugar ke apa ke something like that. Okay, aldehyde kan ada dalam sugar kan. So Fehling reagent consists of basic solution of copper to complex with a deep blue color. Initially it is blue color. So siapa akan bagi positive result to aldehyde? Is it to this Fehling reaction, to this test? Okay, so aldehyde again. Again, aldehyde, this reaction is actually an oxidation reaction sebenarnya sebab dia akan oxidize to carboxylic acid. Ada pertambahan oksigen dekat situ. Okay, so initially it is blue color, then dia akan turn to red color. That represent the copper 1. Initially it is copper 2 becoming copper 1. How about ketone? Ketone give no reaction. Ketone give no reaction. Okay, another test yang dia tak include, mungkin you boleh tambah kot kat situ, lah oxidation. Okay, using CHM096 and KCr2O7. Nampak tak? Ulang-ulang tak? Kan? Ulang-ulang kan? Oxidation test using CHM096 or K2Cr2O7. Okay, sebab aldehyde can undergo oxidation, ketone cannot undergo oxidation. So we can distinguish between these two using this oxidation test. If you are using CHM096, aldehyde will decolorize the purple color. If you are using the potassium dichromate, it will change the color of the solution from orange to green. This is for aldehyde. Ketone will not give positive result either for these two. Okay. Okay. Last but not least is iodophone test. Okay, iodophone test. Kita dah ada dalam alkohol tadi. Ingat? Konsep dia still sama. Okay, dia detect apa? Methyl group. Okay, this is for carbonic compound. Dia detect methyl group juga. Sama. Maksudnya dia lebih spesifik. Okay, the reagent consists of an aqueous solution of I2 in sodium hydroxide or KOH. On reacting with ethanol, a yellow precipitate of triiodomethane appears. Yellow precipitate. Okay, it is a useful test for the methyl ketone group in ethanol and methyl ketone. Can be used to distinguish ethanol from other aldehyde because only ethanol give positive result to iodophone test. Like I said, dia bukan simply nak bezakan aldehyde dengan ketone macam like silver mirror, Fehling, iodophone tu to differentiate between aldehyde and ketone. But iodophone test ni is not like that. Dia bukan bezakan aldehyde and ketone. Okay? Sebab dia punya requirement is very specific. Dia detect the CH3 and carbonyl. Okay? So ketone ada carbonyl. Ketone pun probably ada CH3. Kan? So it is very specific. Dia bukan simply just distinguish aldehyde ketone. No. Okay. So dia boleh, dia nak detect methyl ketone. Okay. Group in ethanol and methyl ketone lagi sekali. Can be used to distinguish ethanol from other aldehyde. Okay, so ethanol dengan other aldehyde and also ketone also. Cuba tengok contoh. Okay, so this is ethanol. Kenapa ethanol bagi positive results to this iodophone test? And same goes to butanol. Okay, but other ketone tak bagi positive result. Okay, for this time around, for carbonyl compound, it detects this one, CH3. Mesti ada CH3 and this O. CH3 and this O. Okay, dia mesti ada this, wajib CH3 ni lah. Kalau alkohol tadi dia kena ada hidrogen kan, but for this one dia tak perlu ada hidrogen. Tapi dia kena ada methyl and this carbonyl. Baru dia bagi yellow precipitate. So as you know, not all ketone, not all aldehyde can have this methyl, betul tak? So kita kena be careful. Kita kena draw, baru kita nampak, oh ni ada methyl. Ada methyl, then probably the molecule can give positive result to iodophone test. Okay, so dia punya detection is on methyl. So ni nama dia methyl ketone. Ini nama dia ethanol sebab ada this methyl. Ni ethanol sebab dia hidrogen. Kat sini dia berapit dengan 2 karbon. Okay, alright. So let's write out checkpoint 30 very quickly based on what we have learned just now. Okay, kena cepat-cepat absorb macam span. Okay, so this is ketone, right? Ketone. So react dengan lithium aluminium hydrate. So nampak je ni reducing. This is reducing agent. Maksudnya reaction dia adalah reduction. Okay, bila reduction maksud tambah hidrogen. Tambah hidrogen. So dia akan jadi alkohol kat situ. Okay, alright. So you lukis exactly sama dengan dia punya material dia starting 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ada 5 carbon. Make sure ada 5 carbon. O tu jadi OH. Right? Don't forget to add in another hydrogen. Kan? Make sure cukup tangan dia ada bond dia ada 4. Kalau you tak tambah hidrogen nanti bond dia ada 3 je sebab ni dah break. How about this one? Ketone. This is ketone. Betul tak? Ketone. And what type of reaction is this? Dichromate. Dichromate is oxidizing agent, right? So when it is an oxidizing agent, react with ketone, ketone will not undergo oxidation. So B not form lah. Okay, takkan terbentuk lah because this is ketone. Faham? Okay, same goes to this one. Kita buatlah C ni alang-alang kan. Okay, so again, this is reduction juga. Basically, you lukis structure tu, structure yang sama. Okay, ni double bond O. Ni adalah aldehyde. Sebenarnya dia ada hydrogen juga sini. Because this is terminal. See? This is aldehyde. Okay, so dekat tempat O tu yang ada double bond tu, dia akan break here. So O you tambah H. Okay, so ni memang ada H kan daripada aldehyde. So you add another hydrogen. Ini daripada aldehyde tadi, yang this one. You add another hydrogen. Okay, so kalau tak tunjuk pun tak apa hydrogen tu. Tapi faham lah maksudnya dia akan jadi alcohol here. So how about this one? Undergoes oxidation. So it will form carboxylic acid because this is an aldehyde. Oxidation kan? Alright, so exactly buat sama. Okay, tempat double bond tu maintain lah O-nya. Okay, dia sebenarnya kan ada H kat situ kan. Sebab oxidation, so kita kena tambah O dekat H tu. Ni baru carboxylic acid. Pada carbon tu So dia memang ada hydrogen kat situ. So you oxidation, you tambah O kat situ. Okay. This is another interesting checkpoint lah. Tapi kita dah running out of time. Saya kena masuk juga. Apa nama tu? The final subtopic which is a carboxylic acid and its derivative. Okay, this is very interesting. You can try out on your own. Kalau kita ada time kejap lagi, kita try buat yang ni. Especially question number 2. So ini type of soalan yang style exam. So try buat. Okay, nampak macam soalan nombor 2 kan? Combine Y with molecular formula of this contain a chiral carbon and form silver mirror with tolerance reagent. Kalau dia bagi positive result for tolerance reagent, okay, maksudnya dia dah bagi hint dekat situ, this should be aldehyde. This should be aldehyde. Cumanya, kita nak tahu structure dia for this aldehyde. C5H10O. It can be apa nama tu, a lot of possibilities having this chemical formula. Betul tak? Dia aldehyde. So macam mana kita nak identify? Lagi satu dia bagi hint dekat situ, chiral carbon. Okay, chiral. Maksudnya this molecule, this aldehyde should have chiral carbon in it. So one of the carbon in this molecule is a chiral carbon. So dia suruh predict the structure of Y that satisfies all the syarat here. Dia ada 5 carbon, 10 hydrogen and 1 oxygen. Dia ada chiral carbon and it gives positive results to tolerance reagent. That means it is an aldehyde. So you try to deduce, dapat tak aldehyde yang satisfies all this. And then the rest will be easier. Okay, ini reduction sebab react dengan this one. This one, oxidation. Once you dah tahu apakah Y, the rest will be easier. Okay, alright, cuba buat dulu. Ada soalan ke related to aldehyde and ketone just now before we proceed to carboxylic acid? Tak tahu madam nak tanya apa. Okay, so far macam mana? Are you guys doing okay? Bertahan ke? Still holding on
Okay.
Okay, madam.
Okay.
Yes, madam.
Okay, alright, harapnya okay lah. Okay, so ini pun agak heavy juga. So balik jangan tunggu lama-lama. Terus je buat tutorial, buat checkpoint, buat balik all checkpoint. Okay, it's just a matter dia nak register dekat dalam otak kita ni. Okay, you dah diintroducekan, saya dah introducekan, and then go through lagi. Lagi banyak kali you go through repetitively, continuously, lagi senang dia lekat. First time memang kita tahu, lambat. Tapi dia dah ada dekat situ, cuma dia hanging kat situ. Dia bertebaran di situ. Tapi dia ada, okay? So you kena puzzle, dia macam puzzle, you masuk-masukkan. So you nak kena strengthen the memory tu, go through lagi. Go through 2-3 kali and you'll be okay. Okay, that is the process of learning. Macam tu proses dia. You don't expect first time tu you absorb 90%. Itu unless you are very genius, okay lah kan. Tapi kita normal people. Okay, kita village people, normal people, memang itulah caranya. Okay, dia punya cara pembelajaran, that is how. You kena train otak you. So, jangan malas lah. Okay, right, moving on. Come on guys, sikit lagi. Carboxylic acid and its derivative. As you can see, we have 4 of learning objective for this subtopic alone. Okay, alright, so I am sure that one of the reaction involving carboxylic acid and ester, you are already, you have been introduced to it during your SPM time. Carboxylic acid react with alcohol to produce ester. Okay, so rasanya you dah belajar kot masa SPM. Tak tahulah kod dia dah keluarkan daripada syllabus kan. So you are quite familiar with the subject matter. Hopefully lah. Okay, right. Structure of carboxylic acid and ester. So carboxylic acid, we have COOH there. Okay, so in general, it can be written as RCOOH. COOH represent the carboxylic acid. So just now kita ada apa nama ni? Aldehyde. This is aldehyde. So kalau carboxylic acid dia ada tambah OH dekat situ sebab aldehyde undergoes oxidation to produce carboxylic acid. So these are the characteristic of carboxylic acid because it is an acid. Okay, the taste is sour, it behaves as weak acid. Example, common example will be citric acid that is commonly found in citrus fruit, ethanoic acid or acetic acid, our sugar, our vinegar, okay, methanoic acid or formic acid, okay, that can be extract ataupun that can be obtained from insect bites and sting. Okay. On the other hand, okay, kalau this is carboxylic acid, kalau ester, dia simply replace this hydrogen with R. That's why ester is a derivative of carboxylic acid. Derivative of carboxylic acid because it can be produced, okay, from carboxylic acid. Sebab they have the same carboxylate group. Okay, tapi dia punya characteristic is slightly different than, is quite different than carboxylic acid. Okay, the ester punya characteristic is different than carboxylic acid. It has sweet odor. Okay, dia punya scent tu very sweet. Okay, it can be made by reacting carboxylic acid with an alcohol in the presence of concentrated sulfuric acid as catalyst. That means dia punya condition should be acidic. Then only you can produce the ester. Okay, so this is the functional group for ester. So basically kalau carboxylic acid dia O dengan H, dia will be terminal lah, dia duduk dekat tepi sekali, terminal. Tapi kalau ester dia ada satu, dia attached with another alkyl group. Okay, so H will be removed and dia attach the alkyl group there. Okay, so we have carboxylic acid react with primary alcohol, for example. Okay, so these are the conditions. So it should be heated and then in acidic condition, you have to use concentrated sulfuric acid. Nanti ada diluted pula. So jangan confuse. Bila nak produce ester, you should be using concentrated H2SO4. Concentrated acid lah sebenarnya. Okay, you will be producing ester dekat situ. So what happen is that water will be removed out of this reaction. Nampak tak? Water will be removed. So water yang dikeluarkan adalah daripada OH from the carboxylic acid and the hydrogen from the alcohol. Okay, so dapatlah O ni datang daripada acid and then this O, another O ni coming from alcohol. Okay. So naming of carboxylic acid, okay, very simple. Okay, macam lebih kurang macam aldehyde lah. Okay, so you have to tambah oic acid at the last name of the carbon, the last name of the chain. Okay, alright. So of course it must be included in the parent chain. Okay, and it must be assigned with carbon number 1. Dia mesti start from that carboxyl group. Okay. And then the rest tu samalah macam biasalah. Okay, you treat substituents. Contohnya kan, kata identify and number the substituent on the main chain. Katakanlah you nampak ada OH group dekat dalam, dia ada carboxyl group and then OH group. So priority kita sebagai parent will be carboxylic acid. Carboxylic acid ni dia punya ranking dia tinggi tau. Okay, kalau lawan dengan other functional group, dia antara yang paling tinggi. So katakanlah kita ada OH hydroxyl group in the same molecule and then we also have halogen in the same molecule or the carbonyl group in the same molecule. So kita punya priority will be based on the carboxylic acid. So nama parent tu akan ditentukan oleh carboxylic acid. Yang lain akan jadi substituents. Okay? Yang lain automatically akan jadi substituents. So kalau OH jadi substituents, kita panggil dia hydroxyl. Kalau jadi parent, kita jadi all kan belakang dia kan. Tapi if it is it becomes substituents, then it will be called as hydroxyl. Okay, so tu sebab dia dah beritahu point kat sini. And then you write the name as a single word. Ini macam biasa. Okay, alright. So you kena identify the longest parent chain that include the carboxyl group. Okay, kalau tak include walaupun you dapat the longest chain tapi tak termasuk carboxylic. No, that is wrong. Okay, jangan prioritaskan yang paling panjang tapi you exclude the functional group. That is wrong. You kena include the functional group. Even though when you include the functional group, you include the carboxyl group, the chain become pendek. Tak apa. Yang penting you must include the functional group. Sebab nama dia tu akan follow parent dia. Akan follow the functional group. Okay, kalau tak ada functional group, macam mana nak namakan parent dia? Kan? Alright. Contoh, example. Jom buat B. Okay, so we're going to start here lah, numbering. Dia kena include. So, kita akan try di sini dulu. Longest and continuous. Ataupun 1, 2, 3, 4. Dapat 4 carbon. How about this one? Four carbon juga. You still dapat 4 carbon. And you ada dua apa nama tu? Dua substituents. Yes, thank you. Okay, madam dah ada dah. Dah lost word dah ni Okay, alright. So, katakanlah saya ambil sini. So, substituent number 1, substituent number 2. So, 1, 2, 3, 4. Butanoic acid. Carbon number 2, we have methyl group and also ethyl group. So, ethyl come first. So, 2 ethyl dash 2 methyl butanoic acid. Okay? Alright. So, boleh try out A and C. Apa dah ni? Ayuh. Berapa slide lagi? Sikit lagi. 10 slide lagi. Sikit lagi. 10 slide. Ester. Tadi dah cakap dah sebenarnya. Okay. Tapi kita go through lah by slide. Okay. Ester. Okay. Just now, kita go for acid. Carboxylic acid kan. Next, how do we name the ester later on? Okay. Alright. So, what is ester actually? So, the alkyl group R from alcohol is named first, followed by the name of the carboxylic acid group. So this is nomenclature of ester. How to name ester? So kita akan kena namakan nama, maksudnya first name dia tu based on alcohol. Dia punya belakang nama parent dia tu akan based on carboxylic acid. Because after all, ester is a combination of alcohol dengan carboxylic acid. So, bila nak namakan ester tu, kita kena consider for alcohol and also carboxylic acid. Tapi macam biasa, carboxylic acid tu dia akan carry sebagai parent dekat belakang. Dia duduk di belakang nama dia tu. Alcohol akan jadi sebagai alkyl group. Okay. So, the alcohol part, alkyl group attached to O of the ester is named as alkyl. The carboxylic part of the ester is the salt from acid and is named as OAT. Tadi OI, ni OAT. Okay, so like I've told you just now, dia punya reaction in order to produce ester adalah you identify carboxylic acid punya part adalah this one. C double bond O. Yang ni akan keluar OH ni. So dia akan combine dengan O daripada O dan R daripada alkohol. So ini ekstra ni akan keluar jadi water. Tapi you jangan confuse lah. OH daripada carboxylic acid yang akan keluar jadi water. Hydrogen from alcohol akan jadi, also akan contribute to the formation of water. Jangan terbalik pula. Nanti dia ingat macam ni. OH yang ni H. Tu you confuse. Okay. Tu you dah confuse kat situ. Ingat. OH daripada carboxylic acid yang akan keluar dan combine dengan H daripada alkohol jadi water. Okay, right. So this part right here yang ada double bond is the carboxylic acid punya part. Then it should end with OATE. Tapi naming untuk the carboxylic acid punya part semua sama macam yang awal-awal yang kita dah belajar tadi. This one is the alcohol part. So ini nak namakan this one. Okay, kita akan nama exactly macam alcohol punya style. Cuma kita combinekan dia and then ends with OATE. Itu saja. Okay, tak payah sembang kencang, tengok contoh. First you kena buat, you kena identify the carboxylic acid punya group dengan alcohol punya group. Okay, cari C double bond O. Kadang-kadang dia duduk kanan, kadang-kadang dia duduk kiri. That's why you kena identify. Look for the carbonyl carbon. Okay, so this is the carbonyl carbon. So the rest adalah carboxylic acid punya part. Yang this one is alcohol punya part. Okay, alright. So bila you nak namakan this one, so you treat separately. Okay, so starting from this carbonyl, so it will be carbon number 1, number 2, number 3. That's why dia propanone sebab dia adalah ester, so it should ends with ATE. How about this one? Sebab dia terpotong dengan O kan, so kita treat dia macam separate. Tapi this one should ends with YL. So starting from O should be carbon number 1, 2, 3. So it's propyl propanone. Okay, senang. Okay, cuba tengok yang nombor 2 pula. Okay, identify carboxylic acid punya part. This one. This is carboxylic acid punya part. Okay, now nak namakan dia. Okay, macam biasa cari the longest parent. So you're going to start from this carbonyl. Dia sebagai nombor 1. Continuous and the longest. 1, 2, 3, 4. So it should be butanone. And carbon number 2, we have methyl group. See, simple je kan? Alright, okay. This part yang O sahaja ni adalah alcohol punya part. Okay, alright. So this alcohol punya part is known as isopropyl. Kenapa? Sebab dia ada 2 methyl dekat situ. And then dia ada 3 carbon. So propyl because dia ada 3 carbon. Iso because it has methyl group. Kalau tak nak pakai isopropyl, tak apa nak pakai style IUPAC yang biasa tu. Okay, nama dia apa? This one, 1, 2, right? 1, 2, the longest. Cari the longest. 1, 2. So it will be ethyl. At carbon number 1, okay, we have methyl. So 1 dash methyl, ethyl dash 2 methyl butanone. Ni nama lain dia. Boleh pakai dua-dua. Okay, alright. Another example, you boleh tengok. Okay, identify carboxylic acid punya part. Okay, ni. Okay, once you dah identify, you namakan dia. Asing Right, 1, 2, find the longest. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sama je, 5. So it will be pentanone. Okay, yang ni straight je pentanone. So we have 2 substituent there at carbon number 4. So we have 2 substituent of methyl group. So 4,4-dimethyl pentanone. Okay, alright, that is for the carboxylic punya part. How about alcohol punya part? Dia ada satu saja carbon. That is, the only carbon. So it is methyl. Methyl dash. Don't forget the dash. Tambah dash guys. Yang dekat yang tak ada dash ni tambah dash. Okay, lepas huruf dengan number kena ada dash. Methyl dash 4,4 dash dimethyl pentanone. Tips dia, identify the carboxylate punya part yang ada C double bond O, itu dia punya carboxylic acid punya part. So dia akan jadi parent. Just change the name, the ending to ATE. Okay, and then the alcohol part dia akan jadi the substituent. Dia duduk dekat depan. Okay, cuba try. Nak yang mana ni? Nak yang mana? C lah. Buat C lah. Macam gerun je C ni kan. Ke ni sama ni? Tak. C Alright. So, kerja kita identify dulu. So, this is the carboxylic acid punya part. Carboxylic punya group. This is the alcohol punya part. Okay. Alright. So, kita start numbering. 1, 2. Find the longest. 3, 4, 5. Paling obvious lah ni kan. Nampak 5 ataupun naik ke atas 5. Okay. So, it will be pentanone. Okay, carbon number 3 and number 4 we have methyl group. So kita ada 2 methyl group. So 3,4 ada 2 ketul of methyl group. So it should be dimethyl pentanoate. Okay, settle for carboxylic acid punya part. Now, kita nak deal with alcohol punya part. Okay, starting from O ni, this should be carbon number 1, number 2, number 3. Continuous kan? 1, 2, 3. Okay, kalau kita nak pecahkan ni, nanti kita tinggal tambah OH je dekat situ. Okay, 1, 2, 3. So, apa? Buat dash dulu. So, propyl. Propyl, right? And then carbon number 2, we have methyl group. So, 2 methyl propyl dash 3, 4 dimethyl pentanoate. Okay, asing dulu. 2 tips untuk buat ester. Betul tak? Ya, 2 methyl propyl, 3, 4 dimethyl pentanoate. Or alternatively, it can be known as isobutyl. Nampak tak isobutyl ni? Okay, this is isobutyl. So, dia ada 2 methyl group yang sama. Therefore, it is iso. Dia ada 4 carbon. So, that's why dia butyl. Isobutyl. Lagi. Tak ada dash. Okay? Try buat. Nak pilih. Aduh. Okay. Settle for naming of ester. Lastly, okay, reaction involving carboxylic acid and ester. Okay, alright. So, kena hafal lah. Ni memang tak ada cara lain lah. Ni memang you kena ingat all the reagents, all the conditions and also the name of the reaction. Okay, so first reaction. Carboxylic acid when you react with thionyl chloride, SOCl2. This is known as thionyl chloride. So, what happened? This is carboxylic acid. How do we know? So, because the functional group. Yeah, with SOCl2, what actually happens is that this OH will be removed out of the carboxylic acid and replaced with Cl. Okay, replaced with Cl. And this is the observation. When you perform this kind of experiment, it will produce white fume that represent the hydrogen chloride, the HCl. Liberated during reaction. This is quite dangerous lah. HCl is acidic kan. Okay, hydrogen chloride. So, maksudnya positive result lah. So OH has been replaced with Cl from SOCl2. And this acetyl chloride can be further treated with ammonia to produce amide. So kan ni daripada sini bawa ke sini. So Cl when you react with NH3, so this Cl can be removed out and replaced with NH2. Ni jangan confuse ya. Di NH2 jangan. Student suka bila dia tahu masukkan tapi dia tu buat NH3. NH2. Dia kena ada 3 tangan kan. Bukan 3 tangan, 3 bond. And this is how it looks like. NH3, neutral kan. So bila dia combine dengan carbon, so one of the hydrogen has been removed. So dia akan jadi 2 hydrogen saja kat situ. Bukan 3 hydrogen so student dia suka ganti terus masuk NH3. Salah. Kalau NH3, dia dah ada 4 bond kat situ. Kalau sini NH3, so N ni akan jadi plus dekat situ. Sebab dia dah ada 4 bonds. N dia kena ada 3 bonds. Baru dia neutral. So that's why dia kena NH2 bukan NH3 bila dia attach to the carbon. Okay. Reaction with alcohol. So carboxylic acid just now can also react with alcohol to produce ester. Ni kita dah well known. So these are the condition concentrated of H2SO4. This is the heat that we have to incorporate for the reaction to take place. Okay. Reaction with reducing agent guys, ni patah balik, pusing-pusing balik. Like macam tadi kan, aldehyde has been aldehyde oxidized into carboxylic acid. Now carboxylic acid reduce. So dia akan jadi, kalau dia pakai strong reducing agent, dia boleh terus reduce the carboxylic acid into alcohol. But very strong reducing agent. Okay, this is very strong reducing agent. So carboxylic acid tu dia tak berhenti ke aldehyde. Okay, dia tak berhenti aldehyde, dia terus je pergi alkohol. Okay, opposite of oxidation reaction. So these are the condition. One more, probably. 350. Okay. Alright, ni draw the structural formula of the product form when ni nantilah. Okay, kita cover this one first. Last one, okay. So reaction involving ester. Just now reaction involving carboxylic acid. Okay. Last one is reaction involving ester. So if we have ester, kita boleh hydrolyze the ester. Okay. So kalau carboxylic acid react with alcohol, it produce ester. Then the reaction name is esterification. This one. And this one. Carboxylic acid react with alcohol, it is known as esterification. Okay. Tapi kalau daripada ester nak reverse balik reaction, it is known as hydrolysis. Kita pecahkan balik dia punya bond. So dia dah jadi satu produk kan. So kita boleh pecahkan dia, kita break this molecule into two, reverse balik. So it will produce propanoic acid and alcohol. Boleh produce balik dia punya original form of reactant. Okay, so condition, kalau nak produce ester, kena pakai concentrated H2SO4. Tapi kalau nak hydrolyze, you kena pakai diluted. Dia kena banyak air. Tapi dia mesti acidic, tapi dia diluted. Okay, diluted sulfuric acid. And it will produce the carboxylic acid and alcohol. Okay, so dia punya tu sama, still acidic, cuma concentrated ataupun diluted sahaja. Okay, so this acid actually react as catalyst sebenarnya. This reacts by catalyst. Kalau without the acidic condition, the reaction will not take place. Takkan berlaku. Okay, alright. If an alkaline is used to instead of acid, carboxylic acid form will be converted to the salt and alcohol. Okay, so it will form salt and alcohol lah. So alternative to acid, you can also use alkaline. Okay, sodium hydroxide. You can also use base in reflux form. So you still break, nampak dia akan break. Nampak tak produk dia tu sama. Cuma dekat carboxylic acid tu dia patutnya dia produce propanoic acid kan. Now the only difference is the hydrogen is now replaced is being replaced with sodium. Sebab O is negative, right? H positive. So that's why they attach, they binds together. Same goes to this one. O is negative. Bila you react dengan sodium hydroxide, the sodium will be attached to the oxygen. Okay, ini yang kita panggil salt. Ini garam lah. But you ada base, alkaline, and this is from acid, right? This is from acid. Okay, so this one will produce salt and alcohol. Okay, just simply replace the hydrogen with sodium. Last but not least, guys. Okay, reduction of ester. Okay, ester can also be reduced. Okay, so this is ester can be reduced to produce 2 alcohol by strong reducing agent. Maksudnya kalau reduction, normally we would pakai this lithium aluminium hydrate. Okay, so these are the condition: lithium aluminium hydrate, ether, H2O+. So what happen is that dia akan break into 2. Dia akan break into 2, sama macam case yang ni, propanoic acid and methanol ni, but okay, dia akan reducekan juga. So supposedly they produce the carboxylic acid kan, and the carboxylic acid will proceed with reduction. So propanoic acid kan, initially, see, kalau dia belah 2, dia produce propanoic acid and methanol. Methanol ni memang dia dah simplest form. Dia tak boleh undergoes reduction lagi dah, nak jadi apa. Kalau alcohol reduce, mana boleh jadi apa-apa lagi dah. Tapi carboxylic acid, propanoic acid, it can be further reduced sebab dia react dengan reducing agent. Okay, it can be further reduced to alcohol. In this case, it is propanol, primary alcohol. Okay, alright. So we have checkpoint 35. Okay, saya rasa S20 S20 you ada kelas kan?
Yes, madam.
Okay, S20 I think you can leave the session. Okay, S19 I think you tak ada kelas kan S19 betul tak? S19? Tak ada. Jom kita buat checkpoint. Saya nak settlekan once and for all lah. Kita buat checkpoint sama-sama and then kita tutup case. Okay, tinggal checkpoint je. Nanti untuk video nanti basically kita dah habis cover. Alhamdulillah. Okay, for the checkpoint coverage S20 you can refer from the video lah which I will upload on YouTube later. Okay, right. So you can leave the session for your next class. Okay.
Thank you, madam.
Thank you, madam.
Alright. Okay, thank you. It's okay.
Thank you, madam.
Okay.
Thank you, madam.
Alright.
Madam.
Yeah.
Thank you, madam.
Right. Okay, jom buat checkpoint 34. Okay, ada ke lagi checkpoint lain? Tak ada kan? Ni semua kita dah buat dah. Okay. Draw the structural formula of the product form when 4,4-dimethyl pentanoic acid reacts with thionyl chloride followed by NH3. Saya faham baru kejap tadi awak belajar kan. Jadi nak absorb tu tak berapa, mungkin lambat sikit. Tak apa, you can always refer to your slide notes. Okay, right. Saya just nak tunjukkan. Okay, how do we start from here? First, you start from the molecule itself. Okay, draw the structure first. Baru you boleh nampak kan what to do next. Okay, how to draw dimethyl pentanoic acid? Pentanoic acid. 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Pentanoic acid. That means 1, 2, 3, 4, 5. Dia ada carboxylic. Okay, always count balik. Cukup tak? 5. 1, 2, 3, 4, 5. Kadang-kadang kita tend to extra lah. Kita tend to write extra carbon. Okay, always count balik. Okay, dia pentanoid. So 1, 2, 3, 4, 5. Okay, the carbon number 4, we have methyl group. So here lah. Another one is here. There you go. Siap. Okay. Okay, first reaction, react with thionyl chloride followed by NH3. Thionyl chloride macam ni rupa dia, SOCl2. Okay, the other one is NH3. Cuba refer balik dia jadi apa, kan? Okay, dia akan jadi, so basically you draw everything the same sebab target dia adalah carbon ni saja. The rest will be the same. Okay, so okay, jadi thionyl, so dia ada O tu still remain, OH ni dia ganti dengan Cl. Okay, ini untuk first reaction. Kalau dia tanya step by step lah. Okay, first reaction. Okay, katakanlah dia react, saya potong kat sini. React pula dengan NH3. Okay. React pula dengan NH3, so malah pula nak tulis pula, nak lukis balik ni. Tak payah lukis, buatlah. Terlebih pula 6. Bukan 6. Okay, so dia ganti dengan NH2. Betul tak? See, ni yang saya tegur tadi kan. It should be NH2, not NH3 Dia react dengan NH3. Tapi when it is added to the carbon, it will become NH2. See, be careful. Student selalu tersalah dekat sini. Okay, right. Tapi kalau soalan tanya just satu ni, maksudnya je this. Jangan lupa. 3, 4, 5. Okay, so this would be your final product. Okay, B. lithium aluminium hydrate, and then H3O+. Identify dulu. This is a reduction reaction because the carboxylic acid is now reacted with, is being reacted, okay, with reducing agent, very strong reducing agent. So it will be reduced to alcohol sebab dia very strong. Dia tak berhenti dekat carboxylic acid, dia tak berhenti dekat, dia macam ni Kalau oxidation, alcohol, oxidize, jadi aldehyde, like I said tadi. Oxidize, jadi carboxylic acid. So kalau you nak reverse, reduce, jadi aldehyde, then reduce, jadi alcohol. Okay, dia just a matter of reversible lah. Bukan saya kata benda tu reversible. It's just that process tu dia boleh oxidize dan dia boleh reduce. Okay, alright. So kalau macam ni carboxylic acid, dia akan jadi alkohol lah. Maksudnya hydrogen will be added to carboxylic acid. So okay, right. So dekat O tu, ni OH kan? So sini, yang double bond tu, dia akan jadi OH. Okay. Yang ni, OH yang memang OH tu, kita kick out the oxygen. So dia hydrogen. And then add another hydrogen, guys. Okay, you add in another hydrogen. Dia macam the oxidation, you tambah oxygen dekat hydrogen. Tapi bila reduction, dia terbalik lah. Dekat oxygen tu, you tambah hydrogen. Okay, so kan kat sini ada OH kan. So kita keluarkanlah O ni. So dia jadi hydrogen saja. And then don't forget, you tambah lagi satu hydrogen. Because this double bond, the double bond will be broken down. Okay, alright. Another C, where's C? Kalau lain. Oh, dia react dengan, this is alcohol with the presence of concentrated H2SO4 and heat. So, this is esterification. Okay, so carboxylic acid you tadi sempit. Okay, carboxylic acid you tadi double bond O, right? OH. 1, 2, 3, 4, 5. Always count balik. Kadang-kadang kita terlebih react dengan ethanol. Okay, ethanol. Saya pindah dekat sini. OH. Siap. 1, 2 kan? 1, 2. So this is ethanol. Okay, alright. So concentrated acid. Ni dia punya reaction. Okay, so kan saya kata OH daripada yang keluar sebenarnya, yang dia akan ada byproduct water, right? OH and this one. Okay. Kenapa tak cantik dekat situ? Sebab tak boleh buat macam tu. Dia kena cut. That's why ada problem kan tadi. Perasan tak ada problem, tak perasan. Hijau. So O and then H. O sebab this bond is attached to O, directly attached to O, not hydrogen, okay? Right, so bila water will be removed, okay, OH daripada carboxylic acid combine with hydrogen from alcohol and produce water, and they basically combine. So produk yang terakhir terhasil pakai color biru. Okay, you buat apa sekarang ni? You lukis exactly the same, you cantumkan dia saja. Okay, you cantumkan dia saja without this OH dengan H. Okay. Enam, 1, 2, 3, 4, 5, 6, 7. Kena ada 7 lah. Okay, sekejap. Tak boleh. Jangan buat macam tu. Okay, kita settlekan for carboxylic acid punya part dulu. Buat satu-satu. Okay. This one kita ada O, right? Okay, so dia ada O dekat sini ni. Jangan lupa. O there. Then, alkohol punya part. Siap. Tak, 4, 1, 2, 3, 4. Betul. Ada tertinggal tak substituents ke apa? So ini dia punya structure of ester. Okay, jom try namakan. Jom nak namakan. Namakan Alright, so macam mana kita nak namakan? Identify the ester first. Okay, identify the carboxyl group punya bahagian dulu, which is this one. Ni. 1, 2, 3, 4, 5. Sebenarnya kita boleh pakai kat sini ni. 4,4-dimethylpentanoate. Jadikan dia, sebab dia bahagian yang sama daripada asid tu kan. Dimethylpentanoate. Okay, how about alkohol tadi? Ethanol. Kan? Ethanol. So, ethyl. Betul tak? Ethyl. Okay, ethyl, 1 ethyl. Sorry. Ni carbon number 1. Ni carbon number 2. So 1 ethyl, 4,4-dimethylpentanoate. So nampak tak apa persamaan dia yang kita boleh extract daripada sini. Kita boleh ambil daripada nama of the acid, just change the ending to ATE. Okay. Tapi ni memanglah kena hafal lah. Thionic chloride, react with NH3. So what will be the product form kan? Tu step yang you kena, bukan step, I mean dia punya reagent tu kena familiarize dulu. Okay. Kan? Ni tunjukkan. OH replace dengan Cl. Then Cl replace dengan NH2. Remain the O. Okay. Alright. Then B, nampak tak? COOH jadi alkohol. Ditambah dekat OH tu, dekat double bond tu jadi OH. And then ditambah 2 hydrogen there. Ada 2 hydrogen. Right? Mana tadi? Ni. Ada 2 hydrogen. Nampak? Nampak ke tak nampak? Nampak kan? Okay. Then C, concentrated H2SO4. This is the ester form. Okay. Okay, last but not least.
Madam.
Ya.
Kan kat soalan tu dia kata draw the structure formula of the product form dia kan. Kalau saya lukis product form tu je, maksudnya tak ada yang mechanism.
Tak ada yang apa?
Dia punya mechanism tu.
Ni ke mekanisme? Mana ada mekanisme? Saya tunjuk mekanisme ke? Ni arrow ni. Tak. Tak ada. Bukan. Saya dah lost word lah sebenarnya. Ya betul lah. Memang produk je. Cuma saya saja je nak menunjukkan dia, nak apply apa yang kita dah buat kat sini kan. Saya nak tunjuk lah. Okay, so this is the starting kan. And then apakah reactionnya ini. Tapi jawapan kalau dalam exam, satu markah dia tanya draw the structural formula. That would be 1 mark for each product form. So kerja you adalah tunjuk product form saja. Tak perlu buat benda ni, tak perlu. Okay, tak perlu. Memang product form saja. Kalau dia suruh name saja. You draw and then you name. Sebab tak boleh nak namakan selagi kita tak ada structure kan. Tu pandai soalan tu Kalau dia suruh name, nervous sikit. Sebab you kena ada structure dulu baru you boleh name. Tapi kalau soalan tanya draw the structure, tak suruh name, tu best. Okay, sebab bila nak namakan tu, imagine kalau you punya compound tu dah salah, of course lah naming salah. Ada banyak kes di mana compound tu betul tapi naming tu salah. So student tak dapat apa markah langsung. So banyak hilang markah dekat situ. Okay? Right. Last question. Draw the structural formula of the product formed when isobutyl butanoate reacts with dilute H2SO4 solute. So reflux. Oh, okay. Isobutyl butanoate. Okay. Jom draw isobutyl butanoate. Okay. Go for butanoate dulu. Okay, kalau ester kita nak start macam mana Kita start macam ni lah daripada the functional group itself. Butanoate. C double bond O. Butanoate butanoate. No. Tak boleh. Ini kita kena ada tips ni. Kalau tak kita akan lost. Kita go for butanoate first Alright. So C double bond O. Okay, and then sebab dia adalah ester, so saya buat alkohol dia dekat this side. Okay, isobutyl. Dia mesti ada this carboxylic punya part ester punya part. Isobutyl. Dia sempit lah pula. Aduh. CH2 then CH3 tak boleh lah sempit-sempit ni stres. Kalau skeletal laju sikit macam ni. O. Okay. Ni isobutyl. Okay, this is isobutyl. 1, 2, 3, 4. Kenapa iso? Because dia ada 2 methyl group. Kenapa butyl? Because it has 4 carbon. Okay. So, kena biasakan ya guna nama isobutyl isopropyl. Buat cantik-cantik sikit. Peluh. Okay. Alright, nak ganti, katakanlah saya nak ganti dia dalam bentuk, tak apalah nak biar macam ni. Dia ada cakap ke nak skeletal ke apa, so saya pun campur. Kalau saya nak, okay. Next, dilute H2SO4 reflux. Ini nama dia hydrolysis. So dia nak pecahkan alkohol ester into its component, which is which are acid, carboxylic acid and alcohol. Okay. Apa ni? Okay. Lama pula okay, pecah. Maksudnya dia akan pecah kat sini. Okay. Alright. So H3O plus heated. Ataupun heated ni kadang-kadang dia boleh represent the reflux. Okay, so you pecahkan. Maksudnya you should have 2 product. Nama pun hydrolysis. Lysis means dia potong. Okay, dia break the bond. Okay, so apa you buat? You dah tahu kan alkohol punya part sini. Carboxylic punya part kat sini. So pecahlah dua. Okay, lukis sebiji jangan ubah apa pun. Tambah OH dah. Tambah lagi C double bond O. Jadi carboxylic acid kan? Don't forget to tambah OH there. Then CH2, CH2, CH3. Nak buat total skeletal pun boleh, tak ada masalah. Siap. Okay, B, NaOH, reflux. Okay, ini dia pakai acid. Yang ni dia pakai alkaline. Boleh juga. dia akan produce alkohol yang sama, guys. Dia produce alkohol yang sama, so you don't have to change anything. It's just that dia punya acid je yang you kena aware, you kena take note sikit. Okay, so you salin balik alkohol dia tu exactly the same. Acid dia tu, this one, OH will be replaced with O. Bukan ganti Na terus dia ada OH kan, bukan OH, I mean H ni. Sebab O tu negatif, so dia akan combine dengan Na. See? Ini. So H ni dia keluar. O tu dia akan combine dengan Na. Siap. Ni alkaline. Tapi alkohol dia remain the same. Last but not least, react dengan lithium aluminium hydride. H3O+. So this is reduction ataupun reducing agent. Maksudnya it will be reduced. Okay. Before they reduce, dia break dulu. Dia akan break sebab dia ada H3O+ ni. Sebab dia ada H3O+, so dia condition tu is already acidic, so it can undergo hydrolysis. And then after hydrolysis, dia akan reduce. Okay, macam biasa akan terhasil dua produk. Okay, alcohol will still remain the same, guys. Alcohol will still remain the same sebab alcohol nak reduce jadi apa lagi dah. Dia memang dah sampai hujung dah alcohol. Dah tak boleh reduce to any simpler form. Salin sebiji. Okay. This is alcohol. Whereas the carboxylic acid will be reduced to alcohol also. So both product are alcohol. Okay. Alright. So macam mana tadi? C. Apa tadi? So double bond yang okay, saya buat dulu yang lain-lain ni supaya kita tak miss out anything. So sepatutnya kat atas ni double bond kan, so dia akan jadi OH. Okay, alright. And then the OH yang memang initially daripada the hydroxyl group tu, kita akan remove the oxygen, so it will be hydrogen, and then another hydrogen will be added. Nama pun reducing kan, so dia akan tambah hydrogen juga yang memang asal tu ada oxygen, remove the oxygen, and the double bond tadi tu dia akan jadi satu bond saja but attached to OH. So that's why dia ada 4 bonds. Okay, so this is alcohol and this also alcohol. So kalau reduction, both product will also be alcohol.